All right, everyone, here's a quick little video to introduce you to what the heck logarithms are. So you'll see there's a log button on your calculator. You might wonder what it does. Well, I just type in some numbers, see what you get. Make a table of values, just like good old previous grades, whatever, before you knew fancy equated versions of equations like y equals mx plus b, you would have just typed in values, right, to see what it looks like. So I suggest pausing the video and typing a bunch of numbers in and making a table of values. So pause. And then now, hopefully you have done a bunch of values, and hopefully it looks something like this. You might have found that you couldn't put negatives in. It was giving you error messages. And yeah, so you put in some values, might have just plugged in a bunch of values and you get a graph like that. So that's what it looks like. Let's just keep going to try and figure out what it's actually doing. So the next step would be to get you to graph as a review from grade 11 exponential functions. Hopefully it's review. So y equals 10 to the x. Graph that. Press pause, make a big table of values, whole bit. Active learning is important, right? So here we go. If you have done that and now you're playing the video again, you have something like that. So take a look at that. What do you think about that? What does that remind you of? So that's my question here. What do you notice? What does it mean about the functions? Press pause, think about it. Try and remember stuff from grade 11. Unpausing now, hopefully you have remembered that, well, hey, it looks like a reflection in y equals x. And hopefully you remember that means they're inverses of each other. Right? Right. So they're inverses of each other. All right, so log is apparently the inverse of exponential. That's what it looks like in GeoGebra. My scales on my graph were not super accurate, so this is much more accurate, but they look very similar. As a quick little review of inverses from grade 11, because it'll be necessary for the course, to get the equation of an inverse, you need to switch x and y because they're mirror image of each other. The x becomes the y becomes the x. So you have to switch x and y. So for this quadratic here, basic, standard, simplest one, switch x and y, and then you're solving for y. Notice you have to do like plus or minus, of course, so you get y equals plus or minus root of x as your inverse. You'll notice that that's not a function because it wouldn't pass the vertical line test, and you can see it graphed on GeoGebra. So I had to graph the top half and the bottom half separate because it can't graph something that's not a function. That's kind of, yeah. They mean by whether it's a function or not, I guess. So anyways, so that's just another example. So what we are getting from this is that mysterious log button is really the inverse of exponential. And so they describe it as like the formal definition. I'm doing it so far on the graph as the inverse of y equals 10 to the x. And so that implies that you have like log base 10. We're actually going to have log base anything eventually in this course. But for now, those are your two versions, and I'll show this on the next slide a little more clearly. But that's just sort of a textbook definition of things. Notice they're saying like that a has to be greater than 0 and a can't be 1. We'll see why very shortly about that. And you saw that in your table of values up here, probably, right? Where you couldn't type in certain values, wherever it was up here. Couldn't type in the negatives and the 0. So back to this slide here. So the next one where I said we're going to explain that a little more. If you have this exponential function, you can do the inverse. And so that's really the exponential form of this logarithmic function. And then to switch to the logarithmic form, you want to be able to do this. You want to think of the 10 as the base. That's going to be a soon. So you're like x equals a to the y. And then the y equals log base a of x. That's going to be your generic conversion between the two. So whenever you see a function whatever the numbers are, you know, you're always going to think, okay, that's y equals, in this case here, the exponential is y equals a to the x. So inverse of that's going to be x equals a to the y. You just switch them just like in grade 11. And then your logarithmic version is y equals log base a to the x. Okay, so you just write that down all the time. Log base a to the x, y equals log base a to the x, and x equals a to the y. And that'll help you transfer numbers between the two. We're not doing it yet because there's some other skills we need to make use of it, logarithm laws and so on. You'll see that in the videos soon. But just to demystify what the heck the log button really is. Yeah, you can have any base there. This is kind of what it goes into here, where if you think of like 4 equals 3 to the power of what, you know, if you're converting between the two, that's what you're going to be doing soon. Not really yet, so I'm just glossing over it. Other versions, of course, you could have base 2. As this one shows. This is an example where base a is greater than 1. So it's like the type we saw because we had base 10. If you have between 0 and 1, then we get this look, and they're both decreasing functions, still inverses of one another, still reflections in y equals x. Yeah. And then finally, almost here, just, you know, because we are inverses of each other, everything's flipped x and y. So I have here the y-axis is the vertical asymptote of the logarithm function. So I should have done that the other way around, I guess. The exponential is the x-axis is the horizontal asymptote. So because the logarithm's the inverse, the y is going to be the asymptote. So the y-intercept of the exponential function is 1. Oh, well, of course, then the x-intercept of the logarithmic function is 1. And then the domain of the range, sorry, of the exponential is greater than, y is greater than 0. And so because log is the inverse, I got that one the right order this time. The x is, right, that should say, yeah, it's x with real numbers, talking about the domain, right? And so the x's are greater than 0. And similarly here, of course, same stuff. Okay, just basically the x's and y's flip. And so this is just a recap of that. Exponential form, right? That's an exponential function itself. There's the exponential version of the logarithmic function. Right? Exponential form, that's a logarithmic function, but it's the, you know, I should write that in or something there. This is, well, they're both logarithmic equations, but I won't type that because, anyways, don't need to. So this is the logarithmic form of that inverse. Okay, so this is the inverse of exponential. That's why I didn't bother typing it, because it's literally, that's what it is. And then this is the logarithmic form of it. So yeah, this is the conversion. You want to always be able to say, oh, so I know x equals a to the y and y equals log base a to x, and they're equivalent, and you're going to transfer between the two. So if we had log base a of x equals y, then you can see it ends up being like the y equals base a of x, right? So you can see how they switch between the two. So you can see that log, if you did know how to do, we don't know how to do yet, but later on we'll see how to do log base 2 of 8, and you're going to see the answer is going to be 3 because 2 to the power 3 equals 8. So that should allow you to see a little bit why you have to have, like, for example, you can't have 0 because, you know, 0 to the power of anything can only be 0. So you can't have 0 to the power of something gives 7. That's what log base 0 of 7 would mean. That's impossible. Same with 1s. 1 to the power of anything is just 1. So I can't have like log base 1 of 7 equals something other than just 1. And the a's can't be negative either because you'd have even odd exponents flipping. It'd be a mess. It wouldn't be a function. It would be discontinuous. It would jump up and down on the y-axis. But main focus of this lesson is just to, you know, like I said, help you realize what the log button is. It really just gives you the inverse of an exponential function. You're going to be seeing all sorts of stuff to do with the log function, log rules, how to work with them, how to solve for exponents. That's actually what the big thing is here. When you look at trying to solve for x. Say we had like, I don't know, 30 equals 3 to the power of x. What the heck's x? You know, how would you solve for that? Well, you're going to convert to logarithmic form, and it's going to tell you the value, because that y value, see here, well, that's the exponent, right? Because we flipped it. And so you're going to actually get the exponent value. So it's going to answer the question. It's going to help you solve for exponents. That's the big goal of this section of the course. I hope that helps get you on the right track. And you're going to proceed with the rest of the lesson, which is the intro video that covers a lot of some of this too on the Jensen site, and then the lesson that goes with the first, or video that goes with the first lesson. All right. All right. What do I gotta do here? And recording is off. See you soon.